Good morning, everyone. Hopefully you can hear me okay. My name is Mike Darracott, and I'll be your presenter for the next 25 minutes. And as Managing Director of MGISS, I would like to thank you for joining us this morning. As you can see, the title of the webinar this morning is Embracing the Digital Twin. This is the first in a series of MGISS webinars that will be running over the next few months, covering topics such as field asset management, the converging and combination of geospatial technologies, and also the role that MGISS are playing in enabling critical infrastructure organisations to be ready for digital productivity and to help reduce risk in field operations, specifically in relation to buried services. And in this case, there's things you can't see. So this webinar really is designed to set the scene. It's an introduction from me to the series that's coming up. What I want to do is provide maybe a little clarity as to what the buzzy language means to us as geospatial consultants, and then you as users. Outline some key industry partnerships and collaborations, key industry drivers, and some of the spatial data challenges to be faced in undertaking a journey to a field-enabled digital twin. So first, some brief explanation to ensure we have a common understanding of the digital twin, its relevance to utility and infrastructure buried assets, and how professional and consumer technologies have converged into solutions such as augmented reality, which is an enabler for improving productivity, safety, and wider social impact. So what is a digital twin? A digital twin is a digital representation of a physical asset, a process or system, or a combination of all three. And this enables a combination of collaboration, insight, and analysis to take place using a single current and sustainable or maintainable version of the truth. In utility and infrastructure operations, a digital twin is of most value when available in the field and in real time. The field-enabled digital twin then incorporates a user device, a robust, generally cloud-based or offline data source, positioning services to tell you where you are within the data, and the digital representation of the physical asset itself. This could be a simple 2D map, a 3D model, or a full 3D visualization. Whilst the map or record of buried assets is critical in advance of any excavation, intervention, or emergency response, the process is often hampered by poor quality data, the timely availability of that data, or difficulty in relating buried asset records to what you actually find in the field. This, along with the convergence of technologies from consumer and professional arenas, such as smartphones full of sensors and accessible software apps, has made immersive applications such as VR and AR a reality. And a note on both of these technologies next. So we need a distinction which is important for those who are relative newcomers to immersive technologies, namely the difference between VR, virtual reality, and AR, augmented reality. Virtual reality essentially replaces what you see. So think in this case, a simulator, whereas augmented reality adds to or augments what you see. Think Pokemon Go or Snapchat for those of you with kids. In this context, the field-enabled digital twin can be established as an augmented reality solution. So what, you may say? However, in our mind, AR is in fact a logical end to the journey that your asset data needs to go on, from 2D plan to 3D model into a field-enabled digital twin. So beyond these important definitions, a summary of the technology components within a field-enabled digital twin or augmented reality solution include the following. Pretty much all of us now have access to a smartphone or a tablet, and that's a key ingredient within an AR solution. Data consolidation, and this is as a result of some sharing initiatives that are happening, and this will be, again, the basis of a future webinar. But we need to have a consolidated data source that can be visualized or viewed within a smartphone environment and be able to deliver it readily and in real time to the same device. What's also needed is the ability to immerse yourself within that model in real time via some on-demand positioning services, and I'll come on to that in a few slides. So what we found over the recent years is the technology really isn't a barrier anymore, nor from a cost point of view or an availability point of view. But we in MGISS really still need a problem to solve, or a series of problems to solve. It's a well-trodden path with technology, a solution trying to find a problem to solve. So at MGISS, we are absolutely clear in our aims to ensure any solution we develop actually solves a real-world problem. We see the increasing challenges facing critical infrastructure as something requiring new ways of thinking. We also see the potential to harness one of the most important assets an infrastructure asset owner has, its data, 80% of which has a spatial component. It's simply a matter then of connecting spatial data to new technology, isn't it? Well, not quite. There's so much of it, and certainly a lot of legacy data, which is simply not fit for purpose in the 3D world. So how do we therefore begin to solve this problem? And the problem we need to solve is being driven by various things around the globe, some of which are local, some of which are regional, some of which are national, and those are international initiatives. So we talk about smart cities, but smart cities are going to need resilient critical infrastructure that relies on data. We have industry standards, BIM as a global standard, and PAS 128 as a UK standard, which is driving better data capture at source. And also the relevance of 3D models within any infrastructure development or infrastructure asset owner process. We also live in an era of increased regulation, which are resulting in fines for non-compliance for utility and infrastructure organizations. Current and recent events, as an example, mean that we need to plan for and respond to incidents in a much more robust and timely manner. And this is really driven by a need for protection of life, land, and also liability or risk. So isn't that enough? Within the spatial data sphere, I think we need to be honest with ourselves, honest with our own systems, and honest with our stakeholders and customers about the accuracy of our data. Why not aim to get it right first time, every time? So as mentioned before, and in summary, what are the requirements for a real-time digital twin or augmented reality solution? Well, firstly, we need good quality 3D spatial data which is fit for purpose. We need suitable hardware, most of which is available and in our hands every day. We need real-time positioning and orientation to be able to immerse yourself within a 3D model. And then we have to consider how we maintain the process in a seamless, accessible, and sustainable way. And we at MGISS call it round tripping. MGISS have been establishing some key collaborations and partnerships with world-leading geospatial technology providers over the last couple of years. This has also led to the development of our topography platform, which has been designed to solve a specific problem and has since been developed to underpin high accuracy GIS data capture for the UK market, aligned with real world problems and with a specific focus on 3D asset data and information management challenges. So MGISS sit within an ecosystem of hardware, software, and app providers. You will find that 80% of utility and infrastructure organizations have some components of Esri GIS technology within their business, along with a huge amount of spatial data. This then we see as a key proponent of us being able to solve this data round tripping problem. And alongside that, we've partnered with companies such as EOS Positioning Systems, VGIS as an augmented reality provider, and other organizations who provide positioning services on demand, such as MGISS systems. So we are going to have a webinar which is coming up in a few weeks' time, which is going to go into a lot more detail about how we have developed the topography solution to underpin a 3D real-time augmented reality solution. But this just gives a brief overview of some of the components that sit within an augmented reality solution. Certainly we need spatial data which is fit for purpose. We need spatial apps. Most of you on the call will have access to Esri mobile apps as part of your enterprise agreement. So you've already got a large component of the solution sitting in your enterprise or business. Add to that components such as an AR platform, VGIS being a solution available, plug and play hardware from organizations such as EOS Positioning Systems and their Arrow series of receivers, which seamlessly connect into any hardware device, whether it's an iOS, an Android, or a Windows device. And then on-demand positioning services, there's been a drive towards high accuracy GIS positioning from companies such as MGISS systems. But there are gaps in all these technologies, and where we've been developing topography is effectively as a glue to join all these parts of the jigsaw together. So we've initially developed data models and workflows to meet the needs of specific application areas in water utilities, highway drainage, and gas utilities, all of which have common node and link type networks that sit below the surface of our streets and fields. Then we have our topography platform, which provides real-time connectivity, real-time coordinate transformations into 3D models, compliance with regulatory requirements, and also a single repository for on-demand positioning services and integration between systems. So this is just really to whet your appetite for what's coming. There's a couple of snippets here of videos that we've been running in the field, and I'll explain what each of them means. So on the left, we have what would be classed as a static augmented reality view. So if you can see what's happening on the smartphone, we have a real-time view through the camera, and then overlaid on that, a feature service which is being pulled directly from an Esri application into the MGISS platform. However, what's needed here is a manual calibration so that there's no real-time position that's accurate enough to overlay the feature service on the device. However, on the right-hand side, we have the integration of a centimeter level GNSS system into your AR platform, which allows you to have a dynamic position as you move and immerse yourself within a model, so that at all times you know your location. You can add new data, you can visualize existing data and attributes, and this then allows you to capture new information and maintain existing data, hence the round-tripping solution. So no webinar which is being broadcast from Liverpool would be complete without a local reference. And here we have an augmented reality solution in an augmented reality environment. And firstly, we see this as the first time that both technology and data has truly come together, and topography provides the glue. So that just gives you a taste of what's possible, what's available within your own organizations at your fingertips, and what with a little effort and using partners such as MGISS and our ecosystem of round-tripping partners to deliver a solution for true seamless 3D data capture, 3D data maintenance, and enabling a field digital twin. So I also want to introduce what's going to be coming next. There will be a webinar announced very shortly around a deeper dive into our topography platform and how we underpin some existing enterprise applications and data to power augmented reality for field operations. We're also going to run a separate webinar which gives a lot more information of how we can support your organizations in being able to manage both new and legacy spatial data in a single consolidated environment. We are also running commercial augmented reality trials, and we're hoping that by whetting your appetite this morning, you may be interested in registering your interest in a round-trip exercise for your own spatial data. Luke, our marketing assistant, will be sending you out a feedback email shortly, and that will allow you to ask any questions, maybe point towards topics that you'd like to see us run through in the future. And also, and I would like to add my thanks for your time listening to me this morning. I hope you found it useful. I hope you will join us for our future webinars. And as I say, if you do have any specific requirements, or you would like us to come and understand what your requirements are in more detail, then please reach out to me on the number or email, and I'll be happy to discuss with you further. Thank you again for your time, and I hope to be able to speak to you again soon.